Hi, this is Mr. Vandergriff, and I'm super excited to go over these lab stations with you. I'm here with Mr. Langhoff, and we are trying to get a better understanding of Newton's third law. So you should know Newton's third law. We've already talked about it and some of the assignments you've already had. So what is Newton's third law? Tell me. Yeah, that's it, right? So for every action, there is an equal and opposite reaction, right? So you're gonna have some experiences, but because we're doing distance learning, we're gonna have to do them for you, and I think you'll enjoy them though. All right, so the first thing I wanna talk about is when you as students, you think of a collision or you think of something colliding, you always think of thinking that are really dramatic, like that, right? Or maybe you think like of two cars coming together and they're just like that, right? Just a big collision. Or maybe it's like a little car and a big car like this, right? But could you believe it? Basically anything, something as simple as slapping this water bottle, wow, that hurt. There's an action and reaction force going on. So we want you to have a greater understanding of the Newton's third law after you go through these lab stations. All right, now these directions for the first station, it's called the Tingling Feeling. They're right here, but you're gonna be more likely online with that. So I need to put on my spectacles here to take a look. So basically what it's asking is just to take your hand, put it on the surface like this, and just lightly slap it like this. Right? You can go ahead and do that again, lightly slap it like this. And then in the directions, it's gonna be asking you a couple questions and then actually doing a force diagram. So let me do the first one for you. Let's take a look up here. What is the boundary of the system? Oh, let's try this pen. There we go. The boundary of the system is going to be here, the table, and then pretty much the air around it, and then me. Now, if you can't draw as well as me, that's okay. I'm a pretty amazing artist, okay? So here I am. Oh, there we go. So there's my hand right there. And as my hand hits the table, let's take a look here. I'm applying a force on the table, but also, let's raise that table. It needs to be a little higher. Something like that. So I'm slapping the table. There we go. Guess what? The table is pushing back against my hand with the opposite and equal force. So you want to make sure the arrows are the exact same length because those are called vectors in physics, and you want them to be equal. So see that? Now, how do I know the table is pushing back? Because I didn't see the table move, right? Because the table's strong, it has a lot of, but my hand is kind of red and it kind of hurts. Now, the second part, take a look here. It says that you need to hit the table a little harder. So here we go. Ah!
Youch!
My hand is really tingling and you can see it's kind of red. Woo! So we're gonna do another diagram here. All right. So again, what we want is we want the table and we want me with my hand slapping it down. And here's my legs. There we go. Now, because I slapped it with more force, what do you think is going to happen? When you draw the diagram, your vectors need to be much larger. But again, so they're equal. So because I'm hitting, so this right here would be the table. This is the reaction table, the reaction force, and this one right here is my hand. So this is the actual action force, and then the reaction force. So hopefully this segment's gonna help you do the first station called That Tingling Feeling. And you know what? My hand's still tingling.